Welcome to the Formulas and Functions 1 participation project for the WV mining problem. This project, we're going to take a look at how we can use some of the basic statistical functions that are built into Excel, as well as how we can write our own formulas to help extract data from our workbooks. To get started, I've downloaded and extracted the starter file from the provided data files. You'll want to make sure that you use this starter file and not a file from an earlier participation project. We're going to start off by working on the coal mine sheet. So I'm on that tab, which is the first one here in the workbook, and we're going to enter some formulas down here at the bottom where we set up this section where we had the minimum, maximum, average, median, and correlation. We're going to start off by going and using the minimum. And we're going to go to cell C60. So that's the one for the 1999 values, and it's the first row right after the total row here. We want to go and compute using the min function what the smallest amount of coal that was mined in 1999 in any county was. I'm going to go ahead and start to enter my formula here. Anytime we go and use a formula or include a call to a function in Excel, we're going to start off with an equal sign. So I've got the equal here, and then the min function will go and compute the minimum value. You can see here that when I start to type in the function, Excel goes and suggests names of functions that I might want to use. And we can tell that they're functions because of the little icon here. I'm going to go ahead and do an open parenthesis, and I need to give it inside of the parentheses the values that I want to go and compare. And in this case, I'm going to compare a cell range. We're going to go and use relative cell references for this. When we do relative cell references, we just go and enter the starting cell, which is going to be C4, and then a colon, and then the ending cell, and that's going to be C58 for Wyoming County. And I'm going to go ahead and hit enter. You can see that the minimum value here was 0 because we had a lot of counties that didn't have any coal. We're going to go now and autofill this formula over through cell G60. What autofilled will do is it's going to go and copy the formula, and then it's going to update the cells that are referenced in it. Let's go ahead and see how this works by autofilling. The autofill handle is in the bottom right corner of the cell. You can see this little square block, and when I hover it over with my mouse, my cursor changes to the plus sign. I'm going to go and click the mouse button and go ahead and drag it over to cell G60, and you can see that it's gone and copied over the formula that I have here. It also went and auto-copied some formatting. It's got that thick border line, which actually I wasn't intending to copy. So if I go to the little tooltip here for autofill options, I'm going to tell it that I want to go and fill without formatting. So that'll go and fill the formula, but it won't change any of the formatting in the cells that I'm copying to. Now you can see here as I go and click through these different cells that the formula changes. What happens when you have a fully relative cell reference, which is what I have here, where it's just the column and the row, nothing else, is that when you go and copy that formula, Excel is going to update that formula based on how many rows and columns you copy. So since, for example, here I copied it over to the right one column, it goes and updates all the cell references so that they point to one column to the right of where they originally were. Since they were pointing at C before, when I copy to the right one column, now it's going to update C to what's right one column of that. It's now D. If I were to go and copy it down, it would go and update the rows in the same way. So instead of being D4 to D58, when I copied it down one, it's going to become D5 to D59. That's how relative cell references work, and those are the most basic type of cell references that you'll see in Excel. Most of the time when we go and use cell references, this is probably the way to go, but there's also some other cases we're going to take a look at here. I'm just going to delete this case where I had autofilled down, because I was just doing that to show this to you. Next, we want to go and find the maximum amount of coal that was mined in any of the counties for each year. I'm going to go to cell C61, and I'm going to start writing the formula here. So I'll start off with an equal sign, and the formula for this is going to be max. And then I need to give max a cell range inside of parentheses here. For this formula, we're going to use what are called absolute cell references. So in the minimum, we were using relative cell references. Here we're going to use absolute, and those are kind of the opposite of each other. You'll see how this works here in a moment. To go and make something be an absolute cell reference, I'm going to put a $sign before the column and a $sign before the row. I can also go through and make something be an absolute cell reference by going and clicking inside of where I have that cell reference and pressing the F4 key on my keyboard, and it's going to go and actually toggle through a couple different options that we're going to be taking a look at. But I'm going to set it here to the absolute cell reference. What an absolute cell reference does is it's going to keep that same cell reference no matter where I copy this formula. So I'm going to go ahead and autofill it over to cell G61. I'm going to tell it again here that I just want to fill without formatting. When it copied, it kept the exact same cell references, so it's still always doing C4 through C58. So this is something that you're going to use if you want to make sure that you're always referring to a specific cell when you go and copy a formula. Sometimes maybe you have a multiplier or something that you have in that cell that you need to use, and you want to make sure that no matter where you copy it, it's always still going to be looking at that original location. That's where absolute cell references are going to be useful. We want to keep these as absolute cell references here, but we need to go and update our formulas so that they point to the correct cells now. So I can go and edit an existing cell's formula by clicking in that cell and pressing the F2 key on my keyboard. The other thing I can do is actually just kind of click into the box here where it has the formula. But we're going to go and change where it says C to D here. So now we'll go and compute the statistics for 2004 in D column instead of 1999. I'm going to do the same thing, just going across. So we'll update to E. F and G. So you can see here over time the largest amount of coal that was mined in any particular county has dropped. Went from 30 million tons in Boone County in 1999 to 18 million tons in Marshall County in 2019. For the average and median, we're going to use what are called mixed cell references, and they're kind of in between relative and absolute. Part of the formula is going to be relative, part of it's going to be absolute here. Let's start in cell C62 and create a call to the average function, and we're going to use a row absolute mixed cell reference. What that means is that the column part is going to be relative, so I'm just going to type in the letter C. But the row part is going to be absolute. That means that the row part will have a $sign before it, and the row part is not going to change if I go and copy that formula. The column will get updated, but the row will not. So I have C $4 colon to C $58. And I can do the same F4 to toggle through options trick as I did with working with absolute cell references, the row above. I'm going to go ahead and hit enter here. So you can see the average amount of coal that was mined per county was about 3 million tons in 1999. And I'll go ahead and autofill this formula over. And again, I'm going to tell it to fill without formatting. You can see the same sort of downward trend in terms of amount that was coal that's mined. But if we go and take a look at the formulas, you can see those up here. You can see that since the column part is still relative, it doesn't have a $sign before it, that got updated when I went and copied the formula across. The row part didn't change, and I wouldn't actually expect it normally to change because I'm copying across the same row. But if I were to copy it down here, and if I didn't have the $, the row part would change. But because I have a $sign before the row, it still stays the same. I'm going to delete that copy there. And let's go and take a look at the last option, and that's going to be column absolute mixed cell references. We'll do that starting in cell C63, where we're going to go and compute the median. So the median is if we went and lined up all of the values sorted in order from least to greatest, and we picked which one was right at the middle. So it's going to generally kind of track the average, but they are very distinct values. For the median here, we're going to go and use column absolute mixed cell references. So I want a $sign before the column part. So $C. The row part's going to be relative, so I'm just going to do 4. And we'll do a colon, $C, 58. So you can see here that while the average was 3 million tons, the median was actually 0. So that means that at least half of the counties produced no coal whatsoever in 1999. I'll go ahead and autofill this over to column G, and we're going to tell it that we're going to fill without formatting. And you can see in this case here, when we look at the formula, it doesn't change because the row part wouldn't change since we're copying in the same row here, but the column part is not allowed to change because of the $sign. Now if I were to copy this formula down, you would see here that since I don't have a $sign before the row part can change from C4 to C5, but again, since there's a $sign before the column part, that's not going to change. What we want to do is press F2 and modify the formula for each of these different columns going across so that they point to the correct location. So we're going to change this to be D instead of C. We'll go ahead and have E, F, and G. We're not going to do anything with correlation right now. We'll take a look at that in a later participation project because it's a little bit more advanced concept. Now we want to go ahead over to the prices sheet. Here in column H, we're going to compute the average price per ton of coal for each of the counties across these different years. We could go and use the average function that we just saw, but there's another way we can go and compute the average. If you recall, the average is just the total divided by how many items went into that total. And there's functions to figure out the total and how many items there are. We're going to go ahead and use those functions because sum and count are very common functions that you'll use as you work with Excel. In cell H4, I'm going to go ahead and type in an equal sign to start off my formula. And I want to get the total, and that's going to be the sum function. So I want to go and sum the values from C4 and then a colon so that we go through G4. And I'm going to divide, so I'll do a slash for that. And I need to come up with how many items are in that cell range. And that's where we're going to use the count function. And for count, I'm going to give it that same cell range, C4 through G4. And I'll go ahead and hit enter. When you're working with things in tables and you go and add formulas, sometimes what you'll see is that Excel will automatically go and insert that formula all the way down. Or in this case, it's actually given me an autocorrect option here to go and overwrite everything with that formula. So I'm actually going to go to autocorrect here with this little tooltip, and I'll tell it to overwrite all cells in this column with this formula. So what it's going to go do is work its way to the end of the table, and it's just going to autofill that formula all the way down, which is what we were looking to do. Let's go ahead back to the coal mine sheet here, and we're going to compute values for column H. In column H, we want to show for the total amount of coal that was mined in 2019, how much of it came from the current county that we're taking a look at. And so what we can do to find that is just take the amount of coal from the current county and divide it by the total. In cell H4, I'm going to start writing my formula here. And I could go through for the amount of coal that's mined in the county, type in G4. The other thing I can do, though, is I can go and actually click in that cell. And you'll see that when I go and click in the cell here, I actually get a little bit different syntax. This is a special syntax that Excel uses when you're working with a table. And what it's saying here with this particular syntax is for the current row, that's the @ sign, we want the value from the 2019 column. I'm going to go ahead and divide that by the total for 2019. So I could go and reference cell G59, or I can just go and click in it, and you can see it's got, again, a table-specific syntax here. So it's saying that from the coal mine table, and it picked up that name because we imported from that file, we want to grab totals for 2019. So this is going to be the exact same result as if we did = G4 divided by G59. I'm going to go ahead and hit enter. And you can see that in this case, Excel went and automatically filled this formula down to all the values in the table. It doesn't do anything in the total row when you go and have it autofill like this. So we can see that, for example, in 2019, Barber County produced 2.4% of the coal that was mined in West Virginia. Marshall County, which was the largest producer, had 18.3%. Now, let's go ahead over to the forecast sheet. And we're going to try to calculate how much coal will be mined in each of the regions in 2024. And then we're going to try to estimate what the value of that coal is using these prices, which were basically 2019 prices for each region that were adjusted for 2.5% annual inflation. We're going to start off by trying to calculate how much coal was mined in each of the regions. And we're going to do this by writing our first formula in cell G6. And the instructions give us a formula that we're supposed to go and use. We're going to start off with the equal sign, and we're going to take the amount of coal that was mined in 2019. So I'll go ahead and click in cell F6 here, and we're going to multiply that, which is a star or an asterisk. And the formula that we want to go through and use is going to go inside of parentheses 1 plus the value for our 2019 to 2024 production rate change. So I'll go ahead and click in cell B4 for that. Now, since this is not a cell inside the table, when I clicked on it, it just put the cell reference. It didn't use the table style referencing. And I'll go ahead and close up my parentheses. Now, one thing that I want to watch for is if I just go and hit enter, it's going to copy my formula down, but you can see it goes and automatically updates that cell reference for B4. And that doesn't make sense. I always want to go through and use this value. So what I'm going to do is go back to the original version of the formula here in cell G6. I'll hit F2 to enter it. I'm going to click in where it says B4. I'm going to go ahead and put in those $signs that we talked about earlier to do an absolute cell reference. When I go and hit enter, it's going to go and update the formula across everything again here. So now you can see they're always talking about B4. And you can see that the total here, it went through and calculated it because we had gone and set up the total row value for this column in a previous project. It's now projecting that production is going to drop to 82 million tons in 2024 from 100 million tons in 2019. In cell I6, we're going to go and try to compute what the value is of the coal that was mined. So that's going to be 2024 tons by the 2024 price. So we're making an estimate for the future here. We'll go ahead and start off our formula with the equal sign. And I'm just going to click and where we have the 2024 tons, which is going to be cell G6. And I'll do a star to multiply and go ahead and click where we have 2024 price. I'll go ahead and hit enter. So you can see that for the central region, it's estimating that we'll have about $79 million worth of coal mined in 2024. It went and filled that formula down. So altogether, the estimate is showing about $7 billion worth of coal mined. The last function that we're going to use today is going to be over on the prices sheet. What we want to do is in column J, we're going to compute the rank for each of the counties with the average selling price of coal mined in that county. So we'll be able to see which counties produce the most expensive coal and which ones produce the least expensive coal. We're going to go ahead and start off by entering an equal sign for our formula. And the function that we're going to use is called rank.eq. And what this is going to do is it's just going to go and give us a number from 1 to, in our case, 55, since there are 55 counties, showing the prices. If there are multiple counties that have the same average price, they're all going to get the same rank. Let's go ahead and do some parentheses so we can go and specify the cells that we want to go through and use for this. This function is going to take two parameters. The first one is going to be the number that we're trying to compare. So I'm going to go and click in cell H4 to say we want the average price for the current row. And then we'll type a comma, and that's going to go and give us the second parameter. And you can see that here in this little tooltip, it's now bolded ref, the second parameter. This is where we're going to specify the entire range that we're trying to compare against. So what I'll do is I'm going to click in cell H4, and I'm going to hold down my mouse and just drag on down to the bottom in H58. And you can see it actually now just says average price. So it doesn't have the @ sign. It means that it's taking the entire average price column. I'll go ahead and close up my parentheses and hit enter. And you can see that it has this value 49 here. And using the autocorrect tooltip, I'm going to tell it to overwrite all the values. So you can see here that we have a lot of counties that had this 5264 value. They're all ranked 12th. And then we're kind of jumping all the way down to, looks like what, maybe 46 or so after that, because we have a couple dozen counties that are all ranked 12th based on their price here. But the lowest county here is Marion County, which had a average price of $50.36 per ton. So its rank is 55. The most expensive county was McDowell, which had an average price of $69.89. So its rank is 1. If you go and use the rank.eq function and you have a table, just dragging the cells to select the entire range like I suggested here in this video is a good way to go through and do that. If you're manually typing in the column and row number, you want to make sure that you do it as an absolute cell reference with the $signs before both the column and the row. Otherwise, this formula is going to cause problems. It's not going to work right. That's something that a lot of people get tripped up with, so I just wanted to mention that. Let's go take a look at the analysis question for this problem. This is going to be question 8b. And the prompt says, in 2019, coal from some counties was substantially more expensive than most other counties. Why might this coal have been more costly? You know, if you think about it, there's any number of reasons why similar products could have different prices. You know, why is a burger at Five Guys more expensive than a burger from McDonald's? For example, there's something slightly different. Yes, they're both burgers, but you have, perhaps higher quality ingredients or something in one of them that's why it's more expensive. In the case of coal, a good analogy would to be thinking about what you might get at a gas station, different types of fuel. All that fuel is going to be made out of oil, but there's different types for different purposes. You'll have diesel that's for trucks and things like that, and then you'll have gasoline that you're going to use in cars, and even within gasoline there's different grades. Coal is kind of the same way. There's different types of coal that are used for different purposes. And that's actually, as it turns out, what the big difference is in terms of price between different West Virginia counties. What's known as metallurgical coal, and that's things that is most commonly found in the southern part of the state. McDowell County has a lot of it, is used as for part of making steel. It's used to go and produce coke that's used in steel mills. Metallurgical coal is much more rare, so it has a higher value than the other major type of coal, steam coal, which is things that basically is burned in a power plant. That's found in a lot more places, and so it's more of a commodity. It's worth less money. So a good response for this question would be counties that have more expensive coal are producing rare types of coal, like metallurgical coal from McDowell County. Because this coal is less common, it is worth more money and yields a higher price. Pretty straightforward answer here. We're not looking for essays, just something that basically addresses the question and tries to provide, a little bit of a why behind it. At this point, we're done with this participation project. You'll want to go ahead, save your changes, exit out of Excel, and go and submit the assignment.